Hi there, Sanjay Gangal from EDACafe. I'm here with Badru Agarwala, CEO of Rise Design Automation. Hello, Badru.
Hello, Sanjay. Nice to have you. Nice to meet you. And good. Thank you for having me.
Well, thank you so much for joining us, Badru. So tell us, first of all, about Rise Design Automation.
So, Sanjay, Rise is a EDA startup,
Mhm.
and our mission is to provide a significant improvement in design productivity, an order of magnitude for hardware design,
Mhm.
and lower the cost of hardware design. Right. And this is to address the challenges of semiconductor need for AI intelligence to do that. Right. So the way we do it in the three steps. The first is that we raise the level of abstraction from RTL to higher level abstraction, high level design language. The second is that we provide the toolchain, RISE as a toolchain for high level synthesis, verification, exploration, so that people can design their stuff at the high level and it can lower it to RTL afterwards and verify that. And the third thing is to have a generative AI solution that we have, right? We take a natural large language model and we produce the high level code on a pre-existing LLM models that we have, right? So that code is very readable, very it's editable, modifiable to do that, right? So our approach is very practical, right? Combination of RISE tool, combination of AI, and also the human in the loop, right? We always have a human in the loop, so they can produce a very optimized RTL code, which is meets the PPA requirement. It's verifiable and it's implementable to do that. So it's a very practical approach that we have come up for designing the hardware.
Okay, now um, the generative AI solution is unique. How does it address common concerns such as training data sources and accuracy?
So that's a good question, Sanjay. So we do it in the three steps, right? The first one is that we do not do the training, right? We rely on the existing trained model, on the large language model that customer is already comfortable with that, right? The second thing is that our large language model, we basically generate the high level model. And large language models are already trained on so much code on C++, Python, and open source stuff. So they are very good agents. They're very good model to produce high level code for the user. But what differentiates is that we have added the agents on that. We have RISE agents that are specialized for high level design, right? So we have three agents to have. We have a high level design agent. So that will produce the code from the large language model. It understands the high level data types. It understands the quality of results. It understands the microarchitecture. It understands the library and will produce the code either in system verilog, it's or in C++ or in whichever language that you want to do that. And it's fully readable, fully modifiable to do that, right? The second agent we have is the verification agent. So that will take your high level data, understand, and it generates the test bench automatically for you, whether it's your C++ test bench or it can be a UVM test bench to do that. It automatically generates your assertions, coverage, debug information to verify, to assist you in verifying your high level model to do that. And the third agent we have is we call it exploration agent or implementation agent. So that's where it understands the technology, it does all your PPA, it runs your synthesis tool, it runs your static timing tool, and it finds out the best optimal solution for the designs that you're looking to do that. But also what is unique to us also that we have this agent talking to our toolchain, right? So it's not just by itself agent rock. So their agents are communicating to the tool and the tool has the knowledge, it can do the real-time computation to do that, right? So what happens is that you get much accurate data, accurate output because the tool has a knowledge, it has a domain-specific knowledge of this stuff, and it is doing the computation to get the desired results to do that, right? So the combination of all the stuff, which makes it unique for us in terms of what we call in the AI solution to do that.
Okay, now many companies have tried to raise the level of abstraction in semiconductor design with mixed success. Now, what sets Rise Design Automation apart from previous high-level synthesis tools and methodologies?
I think it's a good question because this tool has been around for almost 20 plus years to do that, right? And I think there have been some significant challenges. One, it has been limited adoption in terms of number of users you address to it, in terms of what kinds of design style you do it in high level language. So it was only limited kind of certain design style would work in it. The third thing was the quality of results, right? Compared to, more in a hand coded design. And the fourth was mostly in the verification confidence. Can I verify? Can I generate what you generate is, it's very fully verifiable to do that. And the last was the implementation correlation to the implementation data to do that. So what RISE is doing is to overcome those challenges, and RISE solution provides those challenges. And how we do that, I'll show it to you in step by step. The first one is that there are users, we call it architectures and software people. And so there we have a C++ system C, so they can get the design. And this C++ system C is very useful for 100% data part, right? It's fully untimed data parts that you have. So that it's plug and play. If you're already using it, it works very well. But what we have added is a system Verilog, which is very unique. Nobody has provided high-level language synthesis for system Verilog, right? So RISE is the one who is the first industry to provide system Verilog high-level synthesis tool. And that is targeted for the RTL engineers, right? Because they can easily move from RTL to the high-level language incrementally, right? They don't have to give up on the stuff. You still have the RTL code. You still have your verification test pen. So what allows is to it's easily fittable, right? You don't change it, adaptable to your verification environment to do that, right? So that way, then RTL engineers can also move up into the design change to do that. And the third thing that we have done is expanding the field of use of high-level design, right? Normally, it is currently used for data part, 100% data part. And because we have system Verilog is natural language to express your design intent if you have a control part or a data part or timing. And we support that. We have an untimed system Verilog also, and we have a loosely timed system Verilog support to do that. System Verilog is a language, so you can express much bigger design. So we have seen designs which are 80% control language, 20% data part, sometimes 50-50, sometimes 100%. So it's much more expanding the use for do that. So our solution is a little bit more broader for all users, right? For architects, if you're using it, or if you're an RTL engineer, you want to go up into the truth end. The second thing is as you mentioned, was the quality of results, right? How do I produce the quality of results that comes out of it, which is compared to the hand-coded RTL, right? So we have very high-level optimization to do that. We have a AI assistant, or what you call coder, that helps you in terms of guidelines if you need people to do that. We have a very high performance. Our synthesis compile times are in orders of magnitudes compared to the competition, so people can do exploration to do that on terms of it. So we have put all kinds of information to produce the best quality. It has all the debug information, see how the transformation went to do that. And the third thing is the verification, because verification is, as you know, Sanjay, is the most time consuming, resource consuming. It takes more resources to do that. And so we have provided the high level verification in terms of the debugging. We have provided adapters. People can do mix and match verification of your RTL, because not all designs will be in high level, right? Some blocks will be RTL that you have, and you preserve all the information. And of course, we use system Verilog natural ecosystem, the coverage, the UVM randoms and assertions, all of that built into it. So people get confident on that if I can verify my high-level designs, and when I lower it to RTL, it will work very seamlessly to do that. And the last part was that people look at the correlation. How do you correlate to my RTL synthesis or static timing in my place and route? So what we have done is in the high-level synthesis, when we do the scheduling, we automatically call the RTL synthesis under the hood and the static timing to get the better estimate, because high-level synthesis is scheduling at the very high-level operator, and it basically goes and looks at it. And so we do call it, so our correlation data that comes out is much more correlatable to the implementation tool then. And so currently we support open road tools, right? We have integrated, our APIs are very open. And customers can also integrate their own tools. If you have an API, if they want to have production tools that they are using, that they can also implement that stuff to do that. So I think all of this addresses the condition, in terms of addressing all the concerns that people had with high-level designs to do that, right?
And what are some of the major trends and challenges in semiconductor design today, and how does RISE Design Automation position itself to tackle them?
So I think it's so if you look at it, it's unprecedented. I think you're already aware of what's going on in the AI side, on the software side. It's an unprecedented scaling that is going on. And I think the reason that you see that is unprecedented, you have open softwares are available, more people can do open, people are, innovation is happening. There are a lot of startups are doing that. And I think in order to keep up with the demand, I think semiconductor also hardware design also keep up with it, right? We need to do it very much faster rate. We believe that we need 1000x scaling in the by end of this next 3 to 4 years. We need to provide that kind of scaling in the semiconductor to do that, right? And I think no one company can do it. So it has to be collaboration, the EDA innovations happening in there to do that. So a combination of innovation that's happening on the EDA side of it, combination of what RISE is doing in terms of it. And I think customers generally excited about it for the AI solution because they are open for it because they need to increase the productivity, needs to do that, right? And so what we have seen it with the chiplet ecosystem, we see that in EDA, right? Chiplets are coming in the 3D stacking, packaging information coming up. So that will allow people to lower the design cost can easily do that. And so RISE solution fits very well into that solution to do that, right? And I think we have talked to a lot of customers also right now in terms of people are looking for AI, embracing the AI solution to do that. And I think what they like about AI right now in what from the RISE solution is that's more practical, right? Because you can generate an RTL code, but if you're not 100% correct or just 90% is not good enough, right? You cannot have a bugs that
Mm-hmm.
can go into that, right? So our approach, what people find and what customers are looking is much more adaptable, much more verifiable. It's human in the loop, right? We are not trying to take away. It's basically into the loop, more practical to do that. So they really, the trend, which is there's a good trend going on in the EDA side also. So that's we're excited about that.
And RISE recently came out of stealth mode. Where can industry professionals engage with you to learn more, and what events will you be attending in the near future?
So one thing, if we have a website, we have price-da.com that we have the website to do that. We have a lot of video material, the seminars, the webinars are all there into that. We are definitely will be there at DVCon next week. We'll be there at TAC also. We are there. We'll have more seminars coming out there. So we also information on LinkedIn, so people can reach out to us to do that.
Okay, and your website is rise-da.com?
Yes, designautomationda.com. Yes,
Okay.
rise-da.com, right?
And Badru, tell me what in your current set of customers that you have, what size of design are they exploring or creating with your tools? Is it like small, medium, large?
So I think what we have seen is mostly in the area of compute acceleration. People want to accelerate a particular payload that we want to do that. So what we do, I think we see in the three different verticals, people who are doing AI, compute acceleration to do that. The video codec, the AR, VR kind of video processing, it's very highly computational intensive to do that. Communications, those are the three areas that people see. And that they can design the whole system together, right? Not just a simple block, right? What we want to provide is combination of, the complete subsystem so that you can get the performance because Sanjay, all the systems are driven by software now, right? Silicon is driven by the software. So our approach is that when you raise the level of abstraction, you're running the whole software system. So when the silicon comes out, it meets the needs of the systems to do that, right? So those are the three industries we see that verticals to do that. But it can be applied to any other blocks also. If you're an RTL engineer, I want to just do a one particular codec block or a one particular block that I'm doing it, a new block, they can also use it incrementally also.
Okay, and do you integrate easily in the existing design flows from, let's say, Cadence, Synopsys, Siemens?
Oh, absolutely. Yeah. So I think it's very, we sit on top of it, right? We produce the system, the RTL code that plugs into your EDA tool. It goes right into the synthesis tools to do that. For verification, we use the existing simulation environment, right? We use System Verilog, whether it's Cadence or Synopsys or any tools that we have. We fit into the ecosystem to do that. If you have your own designware component or an RTL component also can be integrated into high-level synthesis. So it's very, and I think that's very mindful. We have been very mindful about that because whenever you come up with a new technology, you don't want to, people have invested a lot of thing in their flows and methodologies to do that, both in the front end as well as in back end. So R is very plug and play, drop it into it. And we have all kinds of adapters to work with any of the tools that we have. Right? So we are
And
basically, sitting on incrementally on top of it, right, into Toolchain.
are you selling worldwide?
I think right now we are started in the Bay Area right now. My always goal is that, in 20 mile, this is my fourth startup.
Mhm.
I'm in this EDA for 40 years. And what I have learned is that in Silicon, you have 20-mile radius. You need to get your customers before you go out of there. So I think right now we are focusing, but we are talking to some startups. We have a startup in UK who approach to that. So we are looking at it. So we definitely not bound to any particular stuff. And our solution is a little bit more, we want to go more broader this year. So our solutions are be getting a very good feedback in initial feedback from customers. They're able to use it. And we definitely by end of this year will be going more broader to more geography.
And how many people do you have, and how many do you plan to have by end of the year?
So currently we have 10 people, all of them in US, right? So all of them in Bay Area, mostly in the Bay Area. We have a couple of them in Phoenix and other areas to do that, but it's all in the Bay Area to do that. So currently, I think we are looking for the next phase of explosion. Once we get few customers, once we get that, I think we are looking in the mid-year to go to the next growth of level to do that. So I think we are very mindful to work with the, to make them successful right now, and then go a little bit more broader by the middle of the year to do that, right?
Okay. And Badru, is it okay if I ask you a few personal questions?
Sure, absolutely. Yeah, Sanjay, go ahead.
What do you do for fun outside work, or what is your personal passion?
Oh, quite a few things, right? So people don't know, I think I'm a good ping pong player.
Hmm.
I love cooking. I think a lot of people don't know that I love cooking. I enjoy cooking, in fact, and I like to experiment with that. For the meditation, for mindfulness, I do vegetable gardening. It makes me relax, and how I do this vegetable gardening to do that. The fourth thing that I think in pandemic I started is doing biking, right? So I never used to do bike. I used to do it in India when I was there, but now I do much more biking as part of my habit to do that. And the last thing is spending time with the family and friends, right? So I think that's combination to do that, right? So.
Okay. And final question, Badru. Pets or dogs?
It's a good question. I'm chickens fan, and I used to raise chicken, right? So I've been raising chickens for a long time. So it's been chickens, but definitely I'm okay with dogs and cats. A lot of my friends have it, and so I like to I'm perfectly fine around them, right?
And do you have chickens now in your house?
I think, got out of that mode because, Bobcat used to be, I have a big, Bobcats where, so we did quite a bit of replenishing, right? We get chickens, then, Bobcats would come and take away sometimes. And then so for 10 years, we've been doing it. So now I said, we got out of it for a time being, take a break and see if I want to get back into it. But it was definitely fun. Chickens has been a good fun to do that, right? So that,
That's great. That's great. Well, thank you so much for sharing all this information, Badru. Uh, thank you so much. Have a great day. And hope to see you at DVCon next week.
Yeah, thank you. Thank you for Sanjay. It's great talking to you, right? Thank you.
Okay. Yeah,
Bye-bye.
this is Sanjay Gangal from EDACafe.